Math 2414, trigonometric integrals, integrating a product of sines or cosines, part 5. When we last left off, we were talking about when all the powers were even, and then I said, well, that will always work, what we did, when the powers are even, but I hinted that if they were even and the same, there was another trick you could use, and that trick is to consider using the double angle formula, sine of 2x equals 2 sine x of cosine x, and we're going to use that on this integral here. But before we go any further, I want to give a heads up for those of you who are taking this class because you plan on being physicists and engineers. The calculus that you're seeing now, by the time you're done with your physics or engineering degree, will be the easy stuff. Although I haven't taken an advanced mathematics for engineering class, I have helped people who have. I help them not with the engineering and the physics, but with the mathematics behind it, and more specifically the calculus behind it, and more specifically the integration behind it, and more specifically the integration of products of sines and cosines. So for those of you going down that path, when you take your advanced mathematics for engineering class, you'll look back at the problems we're doing now and go, man, I remember when it was only that difficult, or I remember when it was easy. It takes some getting used to, but just letting you know. All right, so let's integrate sine to the fourth power of x cosine to the fourth power of x. Now, I could use power reducing formulas as before, but we would kind of run into the same dilemma that these both being fourth powers, I would have to write them as sine squared squared, cosine squared squared, replace sine squared with what it equals, replace cosine squared with what it equals, and get ready to do a lot of foiling. And by the way, I can't necessarily avoid all the foiling. And in case you don't know what I mean by foil, I just assumed it. That's just a standard gimmick used in America, possibly outside of America, for multiplying a binomial. First, outside, inside, last. So maybe I should say multiplying binomials instead of foiling. But I want to show you another trick for integrating a product of powers and sines and cosines when they're both even powers and they match. And that's to take advantage of the trig identity sine 2x equals 2 sine x cosine x. So how can that help us? Because this trig identity involves a product of sine and cosine. And if I multiply both sides by 1/2, I get 1/2 sine of 2x equals sine x cosine of x. If your powers match, in fact, this might be a strategy for any time the powers match, not just if they match and they're even. But if the powers match, then you can rewrite it as the product of sine and cosine to a single power. In other words, you write it as sine x cosine x together to the fourth power, and then replace sine x cosine x with 1/2 sine of 2x. Now I still have the fourth power, so woe is me. But at least I only have one trig function now. I would go ahead and raise everything to the fourth power. 1/2 to the fourth power is 1/16. We'll park it outside since it's a constant multiple. And of course, sine of 2x to the fourth power is sine to the fourth power of x dx. Now, if we already had an answer for the integral of sine to the fourth, we could just do a substitution of u equals 2x, create the du package, and then take advantage of those results. And by the way, for those of you who are going down the engineering path, when you get to advanced mathematics for engineers, you will have a lot of previous results to fall back on. So you won't have to be integrating this over and over again, but you will run into situations where you do have to integrate something from scratch. All right, so let's take it from here. And you know what, here's a little trick. When you do a substitution and integration, you normally do it so that you can do the integral. But really what you're doing for substitution is to make the problem easier. Substitutions are always allowed if you think it will make the problem easier. So what I think I'm going to do here is I'm going to go ahead and pull off a substitution of let u equal 2x. It's not going to make the integral integrable, but at least it'll get this 2 out of the way for now. Then du is equal to 2x dx. No, what? Du is equal to 2 dx. It's been a long day. Let's clean this up. So let's go ahead and build this new package just so we can not have to worry about the 2 in front of the x. I need a dx, which I have. I need a 2, which I don't, so I'll drop a 2 in there and balance it with a 1/2. And now everything double underlined will become du. So this is du, and this guy becomes a u. And so now we can focus on integrating 1/32 integral of sine to the 4th u du. And at the end, I've got to remember to put the 2x back in for the u. So don't let me forget, like you can talk to me, this is a recording. We had u is equal to 2x. All right, so let's erase everything except this and move it up to the top, and then we'll continue. All right, so we have 1/32 integral of sine to the 4th u du. And in fact, aside from making that substitution and balancing the du, we hadn't done a look at calculus yet. We've done mostly trig, a little bit of algebra, barely. And let's continue doing some trig by taking sine to the 4th and doing what we do with even powers, which is use a power reducing formula. Sine to the 4th is equal to sine squared of u squared, but sine squared is 1/2 minus 1/2 cosine of 2u. That's the sine power reducing formula. And that parentheses is getting squared, so if we wrote it twice and then multiplied it out, we would get 1/4 minus, actually let's do this. Let's write it twice, but for each one let's factor out the 1/2. So we pull out a 1/2 from each one. 1/2 times 1/2 is 1/4. And when we pull out the 1/2, we get 1 minus cosine 2u. I just think it's easier to multiply binomials when they don't have fractions. I mean, I can do it with, don't get me wrong, you should be able to, but it just makes it a little bit more tolerable. 1/4, and let's not dilly-dally, this is cosine squared 2u minus 2 cosine 2u plus 1. But we're not out of the woods yet, because we still will have an integral of an even power, and so now we have to use the power reducing formula on this guy. 1/4. All right, cosine squared of 2u will be 1/2 plus 1/2 cosine of 4u. Remember, the power reducing formula lowers the power, but it also doubles the argument. So this becomes that, and we still have all this. And at this point, I think I'm ready to integrate. All these trig functions are just single powers. I do have a couple of like terms I should probably combine. So let's go ahead and do that. 1/4, 1/2 plus 1 is 3/2, plus 1/2 cosine of 4u minus 2 cosine of 2u. All right, all of this is really a side thought. I mean, it's not something you would just think and say, oh, well, clearly the integrand is equal to this, but this is classic problem-solving issues. What's in the way and how do we fix it? Well, we have an even power of a trig function, which we can write as a power of sine squared, use a power reducing formula. We still have a product, write it out, factor out the 1/2 because it's cleaner that way, bust it open, look another square, so another power reduction, combine like terms. But we finally got it to a point where we can integrate this guy. We have 1/32 integral of all that. 1/4 times 3/2 plus 1/2 cosine of 4u minus 2 cosine 2u du. Let's see how quickly we can get this done. The 1/4 can come out with the 1/32 to make 1/128. You can check the product if you don't believe me. And now let's integrate each of these things with respect to u. We'll undo the substitution in a moment. The integral of 3/2 du is 3/2 u plus integral of cosine is sine, so we don't change the plus, it stays a plus. But when we integrate this, because if we did a substitution here, the derivative of the inside would be 4, we would balance it with the 1/4 to get 1/8. And again, if me speeding through that substitution move is throwing you off, don't speed through it. Don't say u equals, u is already in play, you need a new variable. Say w equals 4u, play the substitution game, but you'll pick up an extra 1/4, which is why the 1/2 becomes a 1/8. Integral of cosine of sine, 4u. Same thing here. Integral of cosine of sine, we'll pick up an extra 1/2. So that will cancel the 2. And we should have minus sine of 2u. That makes sense because if I take the derivative of this, I get negative cosine 2u. Chain rule picks up the 2. All right. At this point, I think I'm ready to finish it. Plus c. All right. Let's, I don't know if there's an advantage to distributing the 1/28th, but if I've got some fractions factored out, but not all of them, I should either factor out all fractions or not factor it out at all. So I'm going to redistribute the 1/28th, the 1/128th, and that will give me 3 over 256 u, but u is holding the place of 2x. Great, so I got to clean that up. Actually, let's be a little bit more efficient about that. If I put the 2x here, the 2's cancel, leaving an x, so I get 3 over 128x plus 1/128 times 1/8, that's 2 to the 7th, that's 2 to the 3rd, so it's going to be 1 over 1024. I know my powers are 2. Sine of 4u. Well, what was u holding in place of? 2x, so 4 times 2x is 8x, minus 1/28 sine of 2u, u is 2x, so 2 times 2x is 4x, plus c. So, that's all. It's hard for me to say that with a straight face because I know that right now some of you are going, I'll just drop the class, but I promise you, and maybe I should have said this at the beginning of the course, Calculus 2 starts off very rough. I mean very rough. Maybe the integration by parts section wasn't too bad, I hope, but right now we are arguably at one of the pinnacles of difficulty for this class, in my opinion. Once we get past the first test, techniques of integration, it's going to seem a lot easier. It'll still be challenging, don't get me wrong, but don't let a problem like this throw you off. If you know the basic strategy for integrating a product of sines or cosines, you're going to be okay, but you can't be afraid of the algebra, and you can't be afraid of the trigonometry. In fact, over here, it was algebra move, trig move, algebra, trig, arithmetic, because we combine these. So if we were to just summarize, when we did algebra and trig, we did, I gotta remember how to get from here to here. We did algebra, trig, a little bit of calculus when we did the u substitution, and then algebra, trig, trig, algebra, a little bit of calculus, and then we undid the substitution. So I'm not lying when I say you should have a depth grip on algebra and trigonometry, but if you don't, it's not the end of the world. You just can't get scared. For those in my class, when you get to these problems in your homework, please don't hesitate to contact me. I expect you to struggle.